So this is a design question. I read it again and you have to answer me some questions now. A student is investigating the factors that affect the size of the crater a ball makes when it is dropped into sand. Plan an experiment to investigate one factor that affect the size of the crater. The apparatus available includes metal balls, a tray of dry sand. So you can say the weight of the ball, you can say the size of the ball, you can say density of the ball, because anything will affect the size of the crater. State which factor is being investigated. State a key variable to keep constant. List any additional apparatus needed. Explain briefly how to do the experiment, including what is measured and how this is done. State how to obtain reliable results for this experiment. Suggest a suitable graph to be drawn. You're not supposed to draw the graph, but you just have to mention about the approach. These are the lines you have to use. And in the paper, you can always make a diagram. It's always beneficial to make a diagram. So now what should be the plan? If we start our work, I have radius, diameter, volume, mass, height, etc. So these are the factors which I can take: radius of the ball, diameter of the ball, volume of the ball, mass of the ball, height of the ball. Anyone can be taken from it. Not all of them. In the paper, you will be mentioning only one of them. So copy this.
Done.
So can you guide me a plan now? Read the question and roughly give me an idea.
He will need a meter rule and a clamp stand.
Good. And you will drop the ball. You will drop the ball from the same height every time. Suppose you will say, I'm taking diameter. So you will drop the ball from the same height every time and measure the crater. How I can measure the crater? Crater means that the image it produces on sand. So should I use a vernier caliper?
Yes.
Okay. So I can use a vernier caliper. Okay, now copy this, the apparatus work and the variable. I'm just coming, copy this. And I have to ask you that how you will conduct the experiment. Yes, Zainab, can you please tell me how you will conduct the experiment? Just oral is enough. How you will start your answer? Arrange the
Arrange the
apparatus.
apparatus as shown.
Very good.
And measure the time
The
for
apparatus as shown. Yes, then drop the ball drop the ball from the same height every time. Use a, no need to write it. It's obviously the paper is tomorrow. Drop the ball from the same height every time. Measure the diameter of the crater. Measure the diameter of the crater by vernier caliper. Then repeat, reset, yeah, replane the sand again. Replane the sand. Take a bigger ball and drop it from the same height. Then what you now can you add up what we should do after that, after dropping the ball from the different height?
I'll repeat the experiment and take the average.
Sorry.
We'll repeat the experiment and take the average.
Repeat the trial. Very good. Repeat the trial. No, for repetition, remember this concept. Repetition is done for the same ball. Same ball, drop it 3 times and take an average. But when you change the ball, then do not say repeat that. Repetition is for the same trial. Same trial is repeated. Different trials are not repeated. Different trials are actually numbered in a table. Different trials are not repeated. They are different trials are not repeated. They are taken for the different trials are not repeated. They are recorded in a table. Now, how can I make the table? Okay, can you tell me the table column headings? Table, what column I should make?
This for time. Temperature difference.
No, why temperature? Temperature is not needed in this trial.
I think time and
Time is a good choice. But we are dropping it from the same height. Look at our variables. What are our variables? Diameter of the ball and the crater diameter. So there are 2 diameters. So height should remain constant and diameter of the ball, diameter of the crater, and then you drop them one by one, and then you can tell examiner to make a graph. A student is investigating the factors that affect the size of the. अच्छा repeat हो गया. Oh. A student in investigating.
It's the same question.
Achha, this is actually I'm connecting it the a good solution actually. This is our Cambridge endorsed solution. You should look it after the class. This is written by an examiner and how to write the answer. So actually, this is the answer working. You should look it after the class. Examiner comments are there. So actually, the solution marking scheme, and that was the case. A student investigates insulators, plan an experiment to list. Plan an experiment to list insulating discs in order from best insulator to worst insulator. The following apparatus is available. 5 discs made from different insulating materials. 5 discs made from different insulating material, a thermometer, a stopwatch, a heated metal cylinder, a second metal cylinder with a hole for the thermometer. Now, read the question again. Insulating disc, heated metal cylinder. He's making a sandwich here. You can also use other apparatus and materials that are usually available in a school or school laboratory. Explain briefly how you would carry out the investigation. State the key variables that you would control. Draw a table or tables with column headings to show how you would display your readings. You are not required to enter any readings in the table. Explain how you would use your readings to reach a conclusion. So in design questions, it is always advisable to read the question 2 times at least, because question is very, very tricky. So you have to read the question. He says he's checking insulators. Plan an experiment to list insulating this in order from best insulator to worst insulator. The following apparatus is available. 5 discs made from different insulating materials. So he has 5 options for insulating material, and a thermometer, a stopwatch, a heated metal cylinder, and a second metal cylinder with a hole for the thermometer. So I hope you understood the question. He's actually checking the insulator, like when we put something hot on a table, we put a
like
mat.
The time taken for the discs to insulate.
No, the time taken for the temperature to rise. So you must have seen that when you are putting something hot on a table, normally people put a mat under the tea like that to prevent the heat going through. So what he is willing to check, look what he is willing to do. He is willing to check that how much heat flows through the insulating disc, actually electric heater in the top disc. Heat will go down through the insulator. Now, what will happen if there is a good insulator? It will allow less heat to follow. Thermometer will show less rise in temperature. If it is a poor insulator, heat will flow more. If it's a poor insulator, it will allow more heat to flow. And this is an example of insulation. So this is the idea. Now, can you, I have already shown the stop clock. Now, can you tell me what should I do? How should I design? I have given you the main idea.
Compare the temperature difference, temperature is in certain times.
One by one, put all the, put all the 5 insulating materials. For every insulating material, determine determine the rise in temperature. Determine the rise in temperature in a given time. Now, the disc, the insulating material, which will give the least temperature rise will be the best.
Will be the best insulator.
And the material which gives the maximum temperature rise will be the worst
insulator.
Yes. Now table. Initial temperature, final temperature, temperature difference, disk name, time, etc. Now you have to copy this table.
Done.
Good. Now this file is with marking scheme, and let us open the file. You have this file also in print form, right? Check this file. And I think you have a printout of this file also. It is the first design question.
What's the name of this file?
The whole